right? So we came out with an integration by parts formula. But if I let f equal u and g equals v, now let me write something else real quick. What would be this? F prime of x dx, wouldn't that just be du? And what would be g prime of x dx? dv? And let's look at what this formula would read. And I'll write it really big over here. What is that formula now? What does this become? This becomes a what? U. This becomes a v. Subtraction sign, integral of, what's this? V. And this is, all that is just what? V. And there you go. And we'll just say this is going to be our formula for performing the integration by parts. Now you go, what is it equivalent to? Well, it's equal to this. But what we're going to remember is uv minus integral v du to form our problems. You can think, just to help you remember, I don't know what, University of Virginia? Anybody here go to University of Virginia maybe? Ultraviolet. You can call this voodoo if you want, it helps you remember. The integral of voodoo, uv minus integral voodoo. But this is the formula, and we're saying what is equal to it? The integral of, this was what letter? U. That was u? And what was the g prime dx? dv. So I'll just write down, this is what we're saying. The integral of u dv will equal this. And this is called integration by parts. But this is the second major technique to perform an integration, besides the u sums. Okay. So I'll erase this. I mean, that was just in terms of deriving that. And thank you for bearing with me for driving it. Thank you for catching an error when I was doing the product. All right, well, when will we need this? Well, not here. No, not here. I mean, that's a u sub. You all agree? Look at that. Isn't that a u sub? Let u equal to what? X squared. And you do your derivative. What's the derivative of x squared? Now you're on to u subs. The reason u subs are so great is when you have this power difference many times by an integer of 1, right? Or if this was what? Watch this. This was x squared and this was x cubed. Wouldn't a u sub work? X to the 5th, x to the 6th. True? I mean, that's when we're doing these u subs, and we always let u equal this portion. You take the derivative and it knocks this out, right? When do you use this? And I think you'll be able to understand the different scenarios. Not here. It's going to be for something. Whoops. It'll be for something like this. Look carefully at that. This is the one I want to start with. The integral of x sine of x dx. Will the u sub work? You could think, if you want to put parentheses down around x, you can, but u substitution is not going to work. The derivative of x is not x. What's the derivative of x? It's not going to work, the u sub. But the integration by parts method will work. You can think of this as a product. And you can think of this formula here as like the reversal doing that product. Right? So, let's see how we do this. Well, we're going to go off to the side. I'll get this out of the way. Now, let's let u equal something. And let's let dv equal something. Because look at the formula. We need a u and a dv. We need a u and we need a dv. Okay. I'll get u, I'll take the derivative. So I'm going to put a down arrow. Once we let dv equal to something in this expression, then I'm going to integrate. Okay? Let u equal something up there, differentiate. Let dv equal something, and integrate. Cool. The only question is, what should I let u equal to? He's saying x. He's saying let u equal x. Someone else is saying what? Sine of x. Hey, the good news is, if you just try something and it works, great. If it doesn't, you go back and try the other thing. The answer to this is we're going to let u equal the x. All right, we'll talk about that more. Okay, we'll let u equal the x. Then what does the dv have to equal? It's got to be everything else. What's everything else? Excellent. So I'm going to put right over here, sine of x dx. Now I'm going to give you 10 examples in a row. X cosine x, x e to the x. I can keep going over and over, but every time you want to let u equal the x. I go, why? So we can present an acronym for the class to help us know what should I let u equal to. All right, and I'll show you that before you leave, and we'll go over that again tomorrow. The next step, and when I need you to differentiate this x, all right, what's derivative of that? 1. Yeah, just 1. You want to put the dx next to it? Yeah, 1 dx. But now I need you to integrate this. So you let u equal this, differentiate. You let dv equal this, I need you to integrate that. So this will become now a what? This will be a z. Here we go again. And when, is it a positive? Or is it a negative? We're doing this way, so we're going to integral. The integral of sine is a negative cosine of x, right? Alright. And the formula, ultraviolet minus integral voodoo, right? Ultraviolet minus integral voodoo, University of Virginia minus integral voodoo, voodoo. Alright, let's see what we get. This becomes u, v, minus integral v du. What's the u? X. What's the v? Cosine of x, right? But it's negative, so everyone, I'm going to write this and put a little parentheses to indicate the multiplication. But in the end, where should I put this minus? Excellent. Did you hear this? They're saying it's great to rewrite this as negative x cosine of x. So I'll do that in a second. Minus integral, what was v? A negative cosine of x. And what's du? 1 dx. And what's the negative? A plus counter.
Well, why is dv sine of x instead of v equals sine of x?
Why is dv sine of x instead of v?
Yeah.
Outstanding question. I'm going to put boxes for your notes. This, we got to let equal to one portion of this integral. The dv is going to have to be the other. You go, why? Because look what the formula says. You got a u and a dv. So one part, you're always going to let u equal one part. You'll let the dv be the other. But because of that, you let u equal it, you're going to have to take the derivative of this. And the other part you choose, you're going to have to integrate it. Cool? By the way, do you know the real reason he chose let u equals x? Because doesn't this get a lot simpler than an x? Whereas this kind of just stays the same. It becomes another trig function, right? That was really his reason behind letting u equal the x. This got simpler, and it's going to make this integral a lot easier to work. You see what we're able to do? Can't we integrate that now? And we're going to get the final answer. What's this again? Negative what? X cosine of x. What's a minus minus? Plus. Hey, look at my work. Am I finished? Wait, make my accent now. Am I finished? Like, wait, you still got to do what? Integral. Yeah, sometimes students forget that. It's like, wait, I just got to perform that integral right there. What's the integral of cosine of x? And then I heard it plus Charlie, plus constant, plus c. Hey, could you check this to make sure you did it right? How could you check this? If I take the derivative of this, I'd have to use product rule, right? And then I take the derivative of this. I combine it all, what will I get? Yeah, you want to check it? Hey, by the way, this was an indefinite integral, but what if I went from 0 to pi? What would you do for all this? From here to here, you go from 0 to what? 0 to pi. You all agree? I just wanted to point that out. So if you went from 0 to pi over 2, right? Do all that. Yeah, you're like, this was 0, and this was pi over 2. And it was a definite integral. You don't have to do the plus c, right? Right here you'd say 0 pi over 2, and you would put it through all that. Everything gets to pi over 2, and the 0 you subtract. By the way, what would we get? Negative 0 plus 1 minus 0 plus 0. So what's that final answer? Is it negative or just 1? I don't know if you want to check this with your Pt.3s or 84s. You do that definite integral, you have to do it now, but what would you get? 1.0. Okay, let's do one more. What's that? Sine of pi over 2 is 1, right? So cosine of pi over 2 is 0. So I got negative 0 plus 1. With the minus, and then I substitute the 0, but that had a 0 right. Hey, I want to give you one more acronym for our class. I don't care how you want to remember this. If you like ultraviolet, University of Virginia, voodoo, whatever. So here's another one. What did you let u equal to before? Okay. Let's use this. This is what we're going to use, everyone. Lipid. To help us understand what should we let the u equal to. So what I'm just going to say, what should I let u equal to? Question mark. Well, L stands for log. And when if you have a natural log of x in the expression, I want you to let u equal the natural log of x. Okay? I. What's that stand for? Inverse trig function. Right? So if you have an inverse trig function in your what? Integral, and you're doing integration by parts, I want you to let the u equal the inverse trig function. And we go in order of preference, all right? So, all right, my problem did not have a log. It didn't have an inverse trig function. This P stands for polynomial, which I'll whisper can mean like a monomial like x. If the expression has a polynomial piece to the expression, I want you to let the u equal that part. So look at the problem I just did. There was an x, which is a monomial, polynomial, and then a sine of x. Sine of x isn't an inverse trig function, but it's a what? It's a trig function. That t right there stands for trig. And it goes in order of preference. So because poly comes before trig, I'm going to let the u equal the x rather than the what? The sine of x. So many students use this as just a guide to help them understand what should I let the what? U equal to. Okay? Hey, what's E stand for? You probably know exponential like e to the x. Okay? So L stands for logs. If they had like integral of like natural log of x, you'll let u equal to what? Natural log of x. I, inverse trig function like integral of arctan of x. Can you believe it, everyone? In Calc 1, you never did the integral of arctan of x. You found integrals where that was a solution, right? But you never did the integral of arcsine of x or inverse tangent of x. If it has a polynomial, I'll use that. Exponential trigonometry. This is trigonometry, exponential, polynomial, inverse trig, log. It's just a little acronym that helps you remember. Cool? Sean? Oh, like x squared, square root of x. But I would even think some of these.
What about like 2 to 1 half or like?
Yeah, even if you had that, when you have something like that, I still want you to use it. Great question. All right, we'll do one more. And here it is. And when I'm going to give you something, it has 2 things in here, okay? I didn't want to just give, tomorrow we'll do natural log of x, because that's the first one on the list. You'll know to let the u equal to what? Log of x. So here's your last problem. It's an indefinite integral, and there it is. Lipid. What should you let u equal to? Alright, so I'm going to put some blanks here, put this, put this, put this. And everyone, Connor asked me a great question earlier. He goes, why are you using u and dv? We always do that with integration by parts. Something up there is going to get, oh, I forgot my dx, sorry. Something's going to be, u is going to equal something here, and then dv is going to be the remaining part. Well, should I let u equal to e to the x, or should I let the u equal the x? Let's go through this. Any logs in here? Any inverse trig functions? Kaboom. I see one. What are we letting u equal to? Let u equal the x. Boom. So what's dv?
e to the x dx.
Yes. Again, if you're curious, why are we doing this? What's the derivative of an x? 1. But when you do the derivative of e to x, it stays the same, right? This is why this gets cleaner. Allows this problem easier to work. All right, let's differentiate that. We've got it set up properly. What's the derivative of that? Just 1 dx. What's this integral? Dx. All right. Ultraviolet minus integral voodoo. Ultraviolet minus integral voodoo. Voodoo. What's u? X. What's v? d dx. minus integral
e
e to the x dx. And what's the integral of e dx? You all are outstanding. And you know what I want you to compare it to? Look, it's done. Can you compare it to this? Because you'll be in Calc 3, and I want you to decide when you do integration by parts. Minute first. U sub or integration by parts? That's a U sub. Very good. You all know that's a U sub. Let u equal the x squared, you'll knock out that x. But what if it's e to the x and an x? Integration by parts. Hey, I wanted to leave time for problem solving, so great job. If you're okay, yep. I'll see you tomorrow. We're just gonna, tomorrow, finish up this section. Many more examples, then get all your read questions. All right? Great job today, everyone. But stick around if you still got people.